Hello. In this video, we're going to talk about graphing interesting functions with strange windows. So you'll see what I mean when we get to here. So this is an old Algebra 1 Regents question, and it says, a football player attempts to kick a football over a goalpost. The path can be modeled by this function. Okay? X is the horizontal distance, and h of x is the height. Both are measured in feet. On the set of axes below, graph the function y equals h of x, so this guy, on the interval x is between 0 and 150. Okay, so when you have these questions that are talking about like in context, you want to first make sure you label your axes. So it says x is the horizontal distance, so I'll write that down here. And that's measured in feet. And then h of x, or y, is the height of the football. So I'll put that here. And that's also in feet. Okay? So it wants us to graph it. So I'm just going to come up in here and I'm going to graph this guy. All right, so again, control divide 1, negative 1 over 225 x squared minus, make sure you're using that minus sign, control divide 2/3 x. Okay, so I see that it's an x squared. The degree is 2, so it should look like a parabola. Why does it look like a line? Oh, and I did a minus by mistake, so that should have been a plus. So I'm really having fun here. Okay, so it's not even curved. What's going on? All right, so let me reread the question. On the set of axes below, over the intervals 0 to 150, and that's saying my x's. This is a restricted domain. So they want me to graph from 0 to 150, and when I look at my graph, I'm going from negative 10 to 10. So I'm going to change this. I'm not going to make it go to 0 because when I make it do 0, it's going to put that y-axis right up against this wall. So I'll just pick negative 5. Now, to get over to that 10, I'm not going to press enter, I'm going to press tab. Notice how my graph went up here. I'm not going to change that yet. I'm going to go over here, I'm going to press tab one more time, and it said to go to 150. So, I can almost see, guys, that it is, yes, it is going to be a parabola. But what I need to figure out is, what is the vertex so I can see how high it is. So I have a couple of options here. I probably would either go to my table or I would trace. Let's do trace. So menu, trace, and I'm going to change my trace step. The reason I'm going to do this is because if I have it count by ones, it's going to be a disaster because I have to go all the way over to 150. So you know what? I'm going to say, hey, why don't we just try to count by tens and see what happens? Okay, so now I'll do menu, trace, trace step. Oh, menu, trace, graph trace. And that will trace my graph. Oh my gosh, it went right, it went up here, so it's kind of showing me, it went right to my maximum. If I press the left and right arrows, notice how your trace step will snap. I always want my vertex. It's one of my most important pieces to my puzzle here. So I'll do x, h of x, and right in the middle of my table, I'm going to put my vertex, which is the point 7525. Beautiful. So now I need to get some other points here that are worth graphing. And what's nice is with the trace feature, notice how it's spitting out some nice values here. I'm going to grab my x-intercept, which is at 0, 0, and I'll just find some nice points. So my y, I don't want to graph the points, 10, 6.22. So I'm looking for some nice clean points. Oh, this isn't bad, 30, 16. I'll press the right arrow again. 60, 24. That's really nice. And then I've got my vertex at 75, 25. I know that with my quadratics, my y's will be symmetrical, and so will the spacing around my vertex. So I expected to get, 90, 24. Notice the little rainbow, 24, 24. Okay, so I'm going to keep going. 120, 16. I know my next one's going to be my x-intercept, and it's got to be at 0, 150. And again, the reason I know that, 0, 0, 16, 16, 24, 24 with my vertex, the most important point in the middle. So now I have to come over here and plot this. And kids tend to get like scared about how to set up your graph here. I know I have to get to 150 and I know my highest height has to be 25. So as long as over here I can get to 25, I'm good. So I'm just going to count by fives. 5, 10, 15, 20, 25. There we go. Good enough, right? So my horizontal distance, I have to get to 150. So it kind of looks like I can count by like 15s because I have to go 15 to get from 60 to 75. So this will be 15, this will be 30, 60, 75. Oh, it's a little crammed. That's okay. 90, 120 is right here, and 150 is going to be my x-intercept. So I could have spread out a little bit, but that's okay. So I plotted my 0 and my 150. Now I'm going to do my 30, 16. So like about here, and then I'm going to do my other one, 120, 16, same height. I don't know why I like to do it this way. I just do 60, 24. So 60, 24. And then I'll do my symmetrical, 90, 24. And then last but not least, I need 75, 25. Now I just connect them. Nice smooth curve. Okay? So it says determine the vertex. Oh, I did that immediately. 75, 25. Now it says interpret the meaning in context of the problem. So you got to be very detailed here. I've got X and I've got Y. If you get into the habit of labeling things, it's helpful. So with my vertex, 75, that's my horizontal distance. So at 75 feet away, right, is my horizontal distance from the kicker. I think it was talking about a kicker, yeah. The football is how high? 25. And you know what? I'm even going to say that it's a maximum because it is my vertex. Is at a max height of 25. All right, so that's all we have for this graph, the weird window and then interpreting. And again, if you get in the habit of labeling what all of these guys represent, it's really easy to talk about this in context part. They love asking you to write sentences on the regions. All right, that's it.